I hope you all had really good time at the workshops and enjoyed the talks today. Or you're not sleepy, right? My slot was just before lunchtime. I promise I won't keep you longer because I don't want all of you to hate me. But yeah, I hope it's like a lot of breadth of topics to choose from. It's a lot of variety. So I think sometimes you can be just anxious with the decision making that you have to do at these conferences. But anyways, I'm going to try and not dance too much around the stage today because I want to help that person back there to make his job easier. So I'll try. And I'm here to talk about vulnerabilities. And vulnerabilities in the sense from the perspective of a hacker. And I'm not an ethical hacker in that way that runs into bug bounty programs. But I've worked in the cyberspace for some time. And now what I really want to talk about today is more particularly a peek inside a hacker's mind. So what do they actually exploit? And if that's so, how can we as developers and organizations actually help to counter those attacks? How can we start thinking about security as part of our development processes? And so, Mitsu, I wanted to talk about this because today, what secure means today is very different than what it used to mean a couple of years ago in the past, or what it's going to mean in the future. So, how can we actually do that? Let's find out together. First, a bit about myself. I completed my education from Rochester Institute of Technology in upstate New York. I completed it on a Fulbright program. How many of you have heard about it? OK, some people in the room, that's cool. It's an American flagship scholarship program, like an exchange program in the States. I did a master's in computer science, and I've worked in product development areas, software engineering areas, machine learning areas, in the security space as well. And then I also lead an initiative called Stemming from Her, which aims to empower young women and bridge the gender gap that exists in STEM fields in Pakistan. And through awareness workshops and field trips and mentorship programs. I'm originally from there. I currently work in Ericsson's Stockholm office in Kista as a developer. I've previously spoken at several conferences before, primarily technical, most of them. Some of them non-technical as well, closely aligning with tech, but obviously I'm a developer, so most of them have been technical. But today, since I've worked, as I mentioned before, I've worked in product development and development both, close with sales and marketing as well. So I feel like I know something about both of the worlds, and I wanted to share that with you today. Also, like I mentioned, the concept of what security meant before and now has changed rapidly. So today I want to talk about vulnerabilities, more particularly in platforms like Apache STRUTS. I want to talk about how vulnerabilities will affect us when we're talking about serverless applications, and more particularly about cross-site scripting and different types of cross-site scripting and how they affect us and what we should do about them. And some recommendations will follow in the process. So without further ado, let's first look at Apache STRUTS. How many of you have actually used it at your workplaces? Pretty sure some of the Java developers have. And how many of you are like working in big companies, is like giant companies? Like enterprise environments, basically. Yeah, some. I think it's almost the same hands that have shown up. But yeah. So Apache STRUTS, for those of you who have not worked on it, it's actually a well-known development framework for Java-based web applications. It is mostly used for enterprise environments. And it is an open source development platform that actually uses and extends the Java Servlet API that encourages developers to use or adopt a model view controller-based approach to things. So Apache STRUTS, if you search on the web, on Google, for Apache STRUTS related CVEs, you're going to find out that a lot of these vulnerabilities are actually due to one single thing, which is the OGNL injection, expression injection. How many of you have heard about that? Some. Cool. So we'll come to what OGNL expression injection is in a bit. But ideally, everyone gets this. And why that is because a really infamous Equifax hack happened. And this is some time ago in 2017. And what this hack allowed people to do was that it has caused Apache Struts to have a really rough history with many critical vulnerabilities because of this. And the Equifax hack actually allowed credit holders' data that was exposed to the hackers. And this affected actually more than 500,000 of the US population. And the hackers actually got access to all the sensitive information, like the names, like the addresses, personal numbers, social security numbers. So all the sensitive data that you can have in users was actually on the hackers' disposal. And it was just a normal Thursday afternoon 2 years ago when Equifax actually announced that their network had been infiltrated. And because of that, since then, similar hacks or similar attacks have happened, but none of them have had a nerve-touching experience like this one before. So coming back to what OGNL expression injection or OGNL injection really is. OGNL simply stands for Object Graph Navigation Language. It's an expression language for handling Java objects. Now, when an OGNL expression injection, like basically vulnerability, is present, it actually allows the attacker to execute arbitrary Java code. And that Java code can be anything. The worst part is you can use and inject OGNL expressions in all the user-supplied data fields. And if you're getting a response back from the server indicating that this was executed on that side, that just tells the hacker that, yeah, this platform or this application is actually vulnerable. And that's what makes it dangerous. To make it a bit more clear and put it into context, let's just look at an example. Now, you can take this as a sample web form. This is definitely not a web form that UI UX people should be using. I just made it out in plain paint and wanted to demonstrate something. Really simple. I chose these fields for no possible reason. These are just indicators of user-supplied data fields. It's just name, age, email, it could be anything. So let's just say you have a web form which has a bunch of data fields. And you see this form, and you start filling it. It's really common to do registration like that. And what really happens is that if a hacker wants to test for this vulnerability on your platform, what they'll really do is they'll just try out a test expression. Now, over here, this expression in terms where I've put it in the name is just a mathematical expression. But this is just to show that you can enter really simple mathematical expressions to see. It's really easy for you to do that because then you see immediate results. Now, in this case, this expression actually results in a value, in a mathematical value, which is 4 times 74 is 296. Now, if you're submitting HIT on this form, and you submit it, and then you see something like this, in which the entry has actually been added, this is a clear indication that the hacker can actually exploit this vulnerability and finally enter an expression which is much more complex than this, which will allow the hacker to actually steal passwords or read file systems. Now, a recommendation for this, since many people frequently sometimes do upgrade systems and sometimes they don't, A recommendation for this would be for people who have a version lesser than Apache 2.5.10.1, but below that, they should actually upgrade to mitigate these issues, because these vulnerabilities have been there for some time and people exploit them. Now let's come towards serverless. A lot of people are going for serverless now. I remember the time when I was first working as a software engineer, and when they had in-house hosting for things, and things crashed all the time when it was time for deployment and integration and releases. It was a nightmare. Then we moved towards the cloud, and now we see this function as a service concept. This era of going serverless more and more. And there are a lot of benefits of definitely going serverless. First of all, it's really zero administration when it comes to the developer. The developer can actually deploy code without really having to worry about compute instances, or without having to worry about really operating system configurations, and without have to even involve the DevOps team that's on site. So it's like the infra team, or whichever team you may call them, or the IT team, they're not really involved in the process as well. So it's really zero administration when it comes to deploying code from a developer's perspective. It's also auto-scaling. When you're talking about scaling in serverless applications, you're actually talking about scaling in a dynamic way. So it really depends on the load that you're putting on the cloud instance. And it distributes itself. So it's really automatic versus manual. It's also really beneficial to have, of course, a pay-per-use sort of model, and that's how function as a service model works. So you pay according to the resources that you're consuming, and you're not pre-provisioning any resources beforehand. So that helps. It's affordable in that sense. But what about security when you're talking about going serverless? It feels like when you're talking about the benefits, all the workload has sort of like disappeared from the development teams or the developer themselves. But that's not quite the case, because now, when you're serverless, your security responsibility, at least when it comes to the cloud components, like the data center or the network, all the operating system configurations and things like that, they're actually the responsibility of the service provider. However, the responsibility that was once shouldered on the developer's side is actually now shifting to, for example, AWS Lambda or Google Cloud Functions, whatever service you have, it has shifted to there. However, the developer still has the responsibility of making sure that the application data, the flow of information, the logic, everything is correct. And also having a security perspective in mind when they're developing. So what about security? There are definitely new attack vectors that are introduced when you're going serverless. And why I say that is because when we were doing things on desktop, and then we sort of moved to in-house hosting, and then we moved to cloud, and then we moved to these serverless architectures or technology stacks, we're actually changing the work dynamic. And it definitely brings new perspectives. It brings new vulnerabilities. So you need to take care of that. The first thing that you need to look out for is definitely that you have an increased attack surface. And why I say that is because when you're working with applications today, you have a lot of streams through which you could receive your data. So you have message queues. You have APIs, HTTP APIs. You also have cloud storage. So you have a lot of these data streams that are coming to you. And then this actually introduces a lot more complex protocols and complex message structures of the cases that could be valid for it. And because of that, you cannot really have an automated tool to pick those odd ones out. So it's definitely an increased attack surface. Also, it's the attack surface complexity. And why I say that, because serverless functions actually consume data from a lot of places, and it's hard to inspect each and every one of them. And also, because this is a new platform, it's a new architecture stack, it's easy for developers to actually misconfigure things or to make mistakes. And that just brings me to the next thing, which is, of course, the overall system complexity. An overall system is more complex than before, in the sense that it's difficult to actually monitor and visualize this system. So if you want to use metrics or visualization tools, for example, like Grafana, some of you might have used them, it's very difficult to visualize the application end to end when you're talking about serverless. So you need to put in a lot more code for monitoring events, for logging things, to actually detect that a breach has happened in your system, for example, or any other security event. You need to do a lot of logging in the way you're writing code. And of course, there's inadequate security testing. And there has been a history of having web application security tools. That has been there for a couple of years now, and a lot of people are using this. But what does this really mean in the context of when we're going serverless? There are not enough security tools that are doing that on this side of the world. So this is definitely something to watch out for. Some of the recommendations to deal with this is definitely, for the developer, this is to actually map out how your application looks like. So when you're talking about mapping your applications, you should look at three things. You should look at where your data is coming from, what does it actually do, where does it go, and the most important thing is, what is the value for using that data? Let me give an example. When you have an application, you could divide that application into different services and microservices. And when you're doing that on the backend side of your application, you need to make sure that the data that each microservice is accessing, it is supposed to access that data, and it should not have access to any other data. So don't just use that data just because it's easy to fetch that from the table and keep all of it. It's easy if you keep things modular as well, but of course you need to map your application in observing how the data flows and whether you need that data or not. Because the code that you're writing is actually representing the business processes that you have. Then, of course, it's the era of open source and depending on other people's code. So it's not really uncommon to have other people's packages, which are open source, that are actually a big part or the backbone of your technology stack. And so if you're upgrading those packages, it's automated or whether that's manual, whatever the case is, you need to make sure that those vulnerabilities that are creeping into those packages, that can happen, and they don't enter your system. So either you have some triggers or alarms for them, or you're making sure whatever you're upgrading, the third-party dependencies are actually not affecting your work, your project, or your applications, or your product. And then, of course, as a developer, you need to be very vigilant against bad code. And bad code is also contextual in some cases, but bad code in some cases is really absolute. Some things are really, you're not supposed to do that. To overcome the contextual differences that you might have, a good way would be to actually introduce in organizations a process of reviewing code. So when somebody delivers a feature, during the process of working on the feature, you're actually, for example, asking them the approach that they're using to articulate that, and having a peer to support that. It's not like a mentor, but what I mean is you should actually articulate the way you're going to develop things and keeping security perspective in mind. And then in the end, you're reviewing code with people, because at the end of the day, this is going to go to production, and this is going to screw things up. A really good resource that I found for serverless best practices is on Protego. It's a product as well that scans, like a web application security tool, nothing new. But I found this article that was really cool on the serverless best security practices. It mentions a lot of other things that I've not mentioned today, so it would be good to check it out later. And now we come to the main part, cross-site scripting. How many of you have heard about that before? A lot, right? It's a hot topic. Can any one of you volunteer to describe what it is for me? None? Well, this typically never works, right? I've tried this before, but I always do that. OK, so, I mean, it's definitely one of the most common OWASP vulnerabilities that affects both small businesses and big organizations. That's why all of you have heard about it before, or know about it, or know a lot of details on it. Now, cross-site scripting is one of the most common vulnerabilities. And to describe that, what cross-site scripting actually is that when an attacker actually injects malicious code into a website, and that then could potentially affect the user, for example, the user of the website, or the person who that domain belongs to. But essentially, it's about injecting malicious code. Now, most of the people think that it's JavaScript code only, but it could be VB script, for instance, as well. So it's not, but it's about injecting malicious code. Now, since most of you have heard about cross-site scripting or know about it already, you know this thing for sure, and I don't need to go into details, but cross-site scripting has affected platforms like WordPress. And everybody knows about WordPress, I'm sure, in this room. Right? OK, I see nods. So it's a content management system platform and owns almost, you could say, 60% of the market share when it comes to content management systems. And this actually means that a third of the websites on the internet are actually made using WordPress. And WordPress, in March 2019, there was a report where there was one plugin on WordPress which was vulnerable, and then they removed that. There are news like that every now and then. And now in September, they had this editor in, I think it was WordPress 5.0 or something like that, where I think it was called Gutenberg. I don't remember exactly, but it just popped up in my mind, is that the editor was actually responsible for this vulnerability because it could not filter the HTML or JavaScript messages in shortcode. So this actually made the attackers actually use the stored XSS flaw, and that was a zero-day flaw. We'll come to what stored XSS is in a while, but that's what really happened. So when attackers are actually exploiting XSS, what they can actually do? I mean, first of all, they can have access to all the user's cookies that are not protected by HTTP only, of course. And in addition to that, so they can also gain access to session cookies, which means they can also hijack your sessions. In addition to that, what it really means is that the attacker can view everything that the user views. So it can see everything on the website that the user sees. And when it can actually see everything what the user sees, that just means it can also steal information. And not only steal information, since it can inject malicious code, it can also manipulate information because it can make you believe you're seeing something which is not true. And of course, if the attacker has actually been able to successfully have the XSS being executed on an admin, then it can actually do everything that an admin could do. It could actually buy access to your webcams or your microphone and even your location. So that's what it really does. Now, I say this for developers because in order to write secure code, you need to know how attackers actually creep in. So now we're going to go through different types of XSS. We're going to talk about reflected XSS. We're going to talk about stored or persistent XSS. And we'll talk about the DOM XSS. So let's do a short deep dive. Reflected XSS. Now, this is cross-site scripting, which means that the payload is actually reflected. So the server actually reads it from the request, and then it actually echoes it back. That will become more clear if I give an example here. Let's just say you have a website. It could be any website that just searches for products on an e-commerce website. Or Amazon, let's just say. You're searching products there. Now, this is a search query. And so whatever you're searching, you actually echo that back. You searched for this, and then you get that. Now, an attack like this actually requires the attacker to send the link to the user. So the user actually needs to click on this link that actually contains this payload. If the user doesn't do that, then the hacker is not successful. So how can the hacker do that? Typically, the attackers would actually send it to the user in an email. They want to send it into places where they know surely the users are going to click it. Or they could send it into advertisements, like buying advertisements, like sponsored posts all the time, where the attackers know that the user is going to surely visit. Next is, of course, stored XSS. Now, persistent or stored XSS is not when the payload is reflected, but the payload is actually stored on the page. Now, if we assume the same search for items example, then we could see this could be a list of, for example, the popular items that you've searched in the past. So what the attacker can do in this case is that as the JavaScript is actually saved on the page itself, the malicious code is on the page itself, you don't need the person to actually click the link anymore. Because it's depending on where it is saved on the page, you could actually simply wait for someone to use the search box themselves to search for an item, or you could simply just, if it's in, for example, a thread on a forum post somewhere, then you definitely have to send that link and have them click on it. But if that's not the case, you could simply wait for the user to search for it. And this is in stored XSS flaw that they could exploit. The third is, of course, the DOM XSS, or the DOM is the. So when you're really visiting a website, the server generates some HTML and JavaScript code that's actually rendered on your browser. And that's what the user sees, right? Now, you can manipulate what the user sees by manipulating the DOM, by manipulating the JavaScript. And a user will start to see very different things. Now, this DOM XSS, It's a, what do you call that? It's a catch-all term that you're going to use when you're modifying the DOM. And it's a term when it's not, when the JavaScript, which is not interpreted directly from a source, but it is modified afterwards. An example, we could take the same search example, like we did before. An example of this would be if you're now collecting a value, for example, from a URL, and you're trying to decode that. And you're manipulating that JavaScript, and then you're putting it on the page again. Now, when you're looking at this, this would mean that this is a vulnerability that's very similar to reflected XSS. But this time, it will be called the DOM XSS, because this could be, what do you call, a function that uses JavaScript to actually read the value from the current URL and then write it onto the page. Now, this is a very simple example, but DOM XSS could be much more complex than this. For example, it would be JavaScript post message, or it could be when you're sending an XHR request to the server. But it could be much more complex than this. Now, a few key takeaways from this talk is that vulnerabilities, I'm talking about Apache Struts and XSS and Serverless, not because these were the only vulnerabilities, or these are the only threats, or the only platforms that are vulnerable. But the aim of this talk is to start think about the vulnerabilities that exist in your platforms when you're at work, and how you can mitigate them. When you're thinking about them, it's important to consider that there's, in every part of the software development lifecycle, you can start to think about these things. If you're using these platforms, you need to think about what are the ways in which people can breach in. A good way to do this at work would be to have teams that are actually thinking about these things, for starters, and then actually trying to make it a part of the development lifecycle. A lot of the times, security is not considered very important if you're not working in the security domain. If you're working for a company that makes that works in the security, but that does web application penetration testing, for instance, or works on products that are related to that, or sells services like managed security services, then of course you're going to put in more importance into having that knowledge, that security awareness, and to also make it part of your development process. But if you're not from that domain, often at times in smaller companies and bigger companies, what happens is you tend to overlook security. And that's sort of on the back of the plan. Nobody thinks about these things when they're making deadlines or project plans, because nobody really has time for them. But it starts to have dedicated teams who are actually doing that at your workplace, so that, because this is a need of tomorrow. And then, of course, make a difference. And it's not only like product owners or managers who are responsible for that, but developers, they're also responsible for that. Everyone, when they're developing from UI UX designers to the DevOps team, every person part of the chain, of the food chain, should actually start to think about, if we're building this, we should have the security perspective. And we should think about the ways in which this can be broken so that we can fix it. And then, of course, there's a few resources that I found really interesting while I worked in the security domain. So I wanted to share those with you all. If you want to take a picture of it, I could hold for a few more seconds. And with that, I would actually end. You can tweet me any questions that you have. You can email me for a chat. And I think we're running out of time. So if you have any questions, you can actually grab me outside in the coffee area or anywhere, or I'll be here for a couple of minutes. So you can do that. Thank you, everyone.